So I think we all agree that the key metrics for success are play count and listeners. In this video, we'll try and find out what are the chances of you or me becoming at least a somewhat successful musical artist, and what are those minimal requirements you or me have to meet to become a somewhat successful musical artist. And most importantly, is it at all probable? We're gonna use some data science to figure it out. So one of the first things I wonder is there a single metric to actually measure success? I'm guessing it's gonna be track play count, because you get money for the play counts. You don't get money for your listeners, you get money for how many times your tracks are played. So I'm guessing the ultimate metric is track play count and the overall artist play count. Just to remind you all, we have a huge table, a big data set of almost 500k rows. There's 500,000 tracks. The artists vary from The Weeknd to Philip George. Not sure if that's a lot of variation there, but there's a bunch of artists, a bunch of tracks, and for every track we have a track name, track play count, or key metrics. We have track listeners, we got the artist name to identify the artist, we got some technical info, and we got our artist key metrics, artist play count, and the same for artist listeners. So let's dive in and see how these are distributed. This video is about EDA, the exploratory data analysis. The last video was about preparing the data for the analysis, extracting the data via an API, and then formatting it in a data frame. Let's start with the play count first, because it seems the most important one. If we plot a histogram of our play count, we see nothing. What? I'm not sure if you know what we see, but our play counts range from 0 to over 100 million. Not sure if we need to zoom in here, but we sure do need to take a closer look at this area. Right, it starts to look more like a histogram. This little peak here is the vast majority of tracks, and that little tail here is those tracks that brought someone success. That's not too many tracks. It's kind of difficult to study this, so we better focus on a certain area like this one and then zoom in even more to here. That's a histogram. What it shows you is frequency of a specific range of play count. By the way, I'm Vadusha and I'm the greatest expert in data science, programming and music in the entire world, and maybe even on YouTube. 0 to 10,000 streams, there's 160,000 tracks that got play count below 10,000. There's 53,000 tracks that got play count in between 10,000 and 20,000, and so on. Each bar here is frequency, the count of tracks that got in a certain range. So here's the count, here's the ranges. The farther away we go from 0, the less tracks fall in these categories. So the vast majority is concentrated right here. That's the point of distribution. It really is centered around 0. So let's see if there's any actual zeros in there. EDA, or exploratory data analysis, is a set of statistical tools we use to explore the data to see if there's anything worth researching, if there's any trends, if there's any coincidences, if there's any correlations. EDA is the food for further hypothesis testing, data visualization and stuff. That's where we generate potential hypotheses to test later on. We gotta be careful not to jump to premature conclusions, though. Any conclusions we come to in this video, we gotta test later on with proper statistical tools. 25 tracks got 0 play count. Yo, if you publish a song, take some time to listen to it by yourself at least. Make your mom listen to it, make your friends listen to it. Yo, what? Why? And around 2,500 tracks follow this advice. These are the tracks that have their play count at exactly 1. If I put out my track, I make sure I listen to it at least once. There's about the same number of tracks that did it twice, then 3 times, 1,700. Okay, that's barely any streams. Let's see some summary statistics about track play count. We have a total of almost 500,000 tracks, and the average play count is around 200,000, so it's around right here. Does it look like an average to you? To me it doesn't, because the vast majority of tracks are way to the left of that. This is somewhat counterintuitive. The mean as a metric is not valuable here at all, because there's way too many tracks that have a smaller play count, and there's some very few tracks that have ginormous play counts, millions of streams. That is why we're going to be using the median instead of the mean, because the median is a different kind of a central tendency metric. If we look at this distribution right here, here's the mean, the average, and I'm guessing the median would be somewhere around this area. It should show the central tendency, the point of gravity of the whole thing, the center of mass somewhere around here, I feel it is. Let's calculate that mathematically. There it is, 28,000. 28,000 is around here. There's the average, there's the median. And median is more representative of the distribution. It's like when you take a look at people's incomes distribution, and the average income makes no sense at all. It's like here, there's very few people that make a huge lot of money, and there's a ton of people who make little money. And the distribution is gonna be somewhat like that. A lot of data points here, some very few data points to the right, but they're so far outstretched to the right that they outweigh the majority of the data points. And so the average income would be somewhere right here, while the median income would be somewhere here. That's why we're using the median. That's the whole point of it, because it's more representative of our data. One more time, sorry. Say you have 10 people. One of them is 20, the other one is also 20, 20, 20, 20. You get 9 of them, and you get one old man who has been eating his greens, and that's why he's pretty old, 120. And if you want one number to represent the entire group, you get the average, and that would be, add these up and divide by 10, you get 30. What? And 30 represents neither the old man nor these younger guys. That's why the median is useful here, because the median is the center of the row of numbers if you sort it. So the center is 20, and 20 is exactly the number we needed, because we can sort of ignore the old man there and use the most representative number, because this makes the whole distribution skewed a little bit and makes averages useless. That is why we're going to be using the median. That's as clear as I can make it. But both make zero sense actually, because the standard deviation is almost 700k. What? Why? We can say that the mean, or the median, who cares? The median is 30-ish thousand streams plus or minus 700,000. What? This shows that there's too much variability in the data. There's some tracks that are played very many times. There's a lot of tracks that are played fewer times. The variation between play rates is ginormous. And standard deviation is how much on average individual data points differ from the mean. So you take the mean, you take each data point and see how far away from the mean it is. If you average the distances out, you get this. So that's too much variation. Let's break the distribution into tiers. Right, first, write some functions. This one will calculate the confidence interval, which at a certain confidence level will give us an interval where our data is. If we say the median is 28,000 with a confidence level of 95%, where is the actual median? It's going to be plus minus something. So this plus minus something is what we get. This is the something, the CI, confidence interval. Then we'll get a certain summary for those confidence intervals and return the median and the confidence interval to plot it. I got this whole code available in a Google Colab notebook. Go find it with a link in the description, copy it and make changes if you wish, and see if you can find anything interesting in the very same data I'm researching. We see that we're 95% sure that the median is 28,500 plus or minus a couple of thousand. That's more like it. If we take the lower boundary of that, so if we take the median being the most expected play rate you're gonna get if you publish something, and be conservative, we use the lower boundary of the confidence interval. So this number minus this number, we get the pessimistic expectation, the mathematical expectation of what your play rate is most likely going to be. So we do the maths and we get 26,500. How about we plot the whole thing? So we're gonna run the same maths, gonna find the median, confidence interval above the median, below the median, and if our lower confidence interval bound is below 0, which is impossible, we use 0 as the boundary. We do the same with control limits, which are plus or minus 3 standard deviations we've just discussed. It's an imaginary line that is used to track special cause deviations. If a track gets 28,000 plays, that's a normal situation, that's the median situation, that's the mathematical expectation. But if it gets 1,000,000 plays, is it normal or not? That's what the formula is doing. It takes the standard deviation, and if the outlier data point is 3 standard deviations away from the central tendency, it's an actual outlier. There's a special cause causing it to lie that far out. That's process control, used at factories, at actual manufacturing facilities, plus or minus 3 standard deviations. These are going to be lines on our chart. It all is going to make sense once we've plotted it. Right, then we build the actual chart. We add the lines as vertical lines. V line stands for vertical line. Plot the median as a green line. We add dotted green lines as confidence intervals to show that the median is a bit below blurred. And then we got the red lines marking control limits. We build the thing, add the data, and boom, there we go. Nothing much to see here until we zoom in. Oh, by the way, this is the second video in the entire series, so go check out the other videos with the link in the description. Everything above 2.1 million plays is an outlier for sure. There's the median. It almost looks like it's one line there. It does look like at around 180 something, it flattens out. So let's set 180 as top tier limit. You see the median, dotted lines, they are confidence interval. So our median is actually within these dotted lines. Let's set the threshold for the good tier. We said our okay play rate was 26,000. This little line here, 26,000. Let's set that as the good tier lower threshold. The top tier threshold would be anything outside the red line. This red line, anything here is top tier unreachable. BTS, Charlie Puth, One Direction, Billie Eilish level. We're all aiming there. It's not very likely we're gonna achieve that. Let's see what the top tier tracks are. Boom. The Weeknd, Jimi Hendrix, pretty popular stuff there. A total of almost 7,000 tracks. 7,000 tracks here. The rest of them are here. Now let's isolate anything below the red line. There's too many outliers that skew our picture. If we take them out of the equation and recalculate the boundaries with a different level of variation, we get somewhat adjusted lines. This red line moved to the left a little bit, and now the outliers are those outside 150. So let's see the lowest bar there, 500. So anything below 500 is something you need to pass to start going. It's pretty high. 53,000 tracks are in this category. So that's gonna be the bottom tier. That's something we need to pass. At least 500 streams per track is what we're aiming at. That's the threshold we need to surpass. Let's recalculate the whole thing again, see what the green line is, redo the good tier threshold, mid tier threshold. So we see the median went down a bit, and the mean actually went down when we cut out the outliers, reducing the variation. Now the median is 16,000 and the confidence interval is way more narrow. So we take the lower part of the confidence interval and use it as our threshold. Now we assign those tiers, put them in a dictionary, write a function to assign tiers to each track. The function will iterate through all of the 5 tiers and see if the track's play rate is within the tier. And if it is, it'll assign the number. If not, it'll go to the next tier until it reaches the tier it falls into. So we do that, assign data, and see what happened. Weeknd, 20 million plays, got tier 5 for sure. Okay, how many tracks fall into each of the tiers? So tier 1 is below 500, tier 5 is way outside 2 million. Let's visualize the counts. I don't like it in a table. There you go. That's tier 5, very small. Tier 1, almost 11%. Tier 3 being the biggest slice of it. Let's do it this way. 1, 2, 3, 4, 5. Almost 5,000 tracks fall into category 1. Almost 3 times more tracks fall into the second category, and so on. I guess you get the idea. And the point is, it's very hard to get into tier 5 outside 2+ million plays. But you're more likely to go to tier 3 or tier 2, and literally 3 times more likely than go into tier 1. That means once you surpass 500, you're good to go. Let's do the same for listeners. So we got this picture, we got the lines, we got a long tail, which will cut. Let's see what the lowest tier is. 1,000 listeners. Okay, we got the median at almost 7,000 listeners. Let's get the thresholds. 1,000 for the lowest tier. Top tier is +3 standard deviation from the median. And the great tier is somewhere, let's say 34K. Got that. Let's cut the outliers. We got a bit of a different distribution right here. Let's zoom in and see if anything changed. It went down from 1,000 to 100. Let's set the bottom tier to 100. Got that. We got a new median. Let's set that. The confidence interval is very narrow, 26. Assigning the tiers. You get the idea. Kind of the same picture. I wouldn't expect listeners and play count to be very different. It kind of leads us towards the thought that the more listeners you have, the higher play counts you get, which seems logical, but we need to test that. Let's scatter plot the two variables against each other. Okay, the more listeners, the higher the play count. Affirmative. And there's a weird thumb kind of looking tail of outliers. Who are these? This means that there's tracks that have less listeners than a lot of the tracks, but so many streams per track that they're outliers here. Who are they? BTS, okay, BTS, BTS. Right, we clearly see that the more listeners there are, the more streams the tracks get. What if we try and see how many streams per listener a track gets as a virality metric? So if one track gets listened by one person multiple times, the track must be more successful, right? More viral, probably. Let's see how far can this go. Let's calculate virality, dividing play count by listeners, and see the distribution there. Man, I want you to stop right there for a minute and take a look at this. This does mean that some tracks get listened on average 3,500 times. One track by one person 3,500 times. What? Sounds insane. I don't really believe that. Let's see the top 10. I got no idea how this works. That's someone from BTS. 46 listeners. I mean, 46, not 4,600, not 46 million. 46 people. You can get those in this room. And they provided a total of almost 200,000 plays. That's incredible. All right, this one's got one listener. 2,000 times. One person. One actual literal person. Nobody else in the world listened to this very song. That's the spirit. I would claim that anything above 50 plays per track is somewhat suspicious. Let's isolate those in a separate dataset called 2viral and plot that. Okay, most of them are kind of normal, below 10,000. Generating huge play counts with below 10,000 listeners is BTS-ish, I guess, because that's all BTS. That's some huge virality. Let's isolate the tracks that are too viral but have too few listeners, like below 50. It goes even below 10. Huge play counts from very, very few people. That's weird. Who are they? Who's Strawberry Guy? Okay, let's filter out the tracks that have over 50 plays per person but less than 10 people listening. And that's 374 tracks. Do you see any familiar names there? Wasia Project, Lily Kincaid, Dude, MC Josh. Who are these people? I mean, we'll delete those. We're keeping the tracks that are either less than 50 plays per person or over 10 listeners, so that we don't have thousands of plays per person when it's like 10 listeners per song. And see the new distribution. Zoom in. There's a bump there around 1. Let's say 1.5 is the bottom tier. There's a bump at around 3. Let 3 be the threshold number 2. Let 5 be threshold number 3 to 8. Everything above 8 be the top threshold. Okay, let's assign the thresholds, visualize the whole thing. There you go. Kind of the same. Now we got the tiers down. Let's sum it up. If you're an aspiring artist and you issue a track, your first milestone is 500 plays for your track, and your probability of going past that is actually pretty high, 89%. So you're pretty likely to be above that, and you're still pretty likely to be above 16,000, which is like the realistic play count. So almost half of the artists are above that level. You're pretty likely to be above that level. Not for sure, but pretty likely. Kind of the same numbers for track listeners in terms of probability. About 100 listeners is a bottom threshold you need to surpass to somewhat get in the game. But once you're there, you're still pretty likely to reach about 4,000 people listening to an individual track of yours. So these are unique listeners. As for virality, 1.5 listeners per track is pretty likely. It's pretty easy to get somebody to listen to your track at least twice. And the average is around 4 listeners per track. Let's look at the same kind of metrics, not for individual tracks, but for artists. If you're an artist, how many plays should all of your songs get in total? How many unique listeners you as an artist should have? Same kind of questions there. So let's narrow it down, assign those tiers. You get the idea. There's the distribution as the thresholds, kind of the same picture there. You're still more likely to go to tier 2 than stay in tier 1 once you're there. There's the listeners, which are distributed kind of the same way. And there's the tiers for listeners. Tier 4 is less likely than usual. Then artist virality, which is average plays per listener across one artist. For your entire artist backlog, how many times on average a person listens to a track? Kind of the same there. That's track play count against listeners. It looks almost exactly the same as the artist play count against the listeners. These are the outliers: BTS, the funky one Taylor Swift, Lana Del Rey. Here's Coldplay being the most balanced and far out. Right, let's summarize the artist metrics. Okay, so you're 90% sure to get outside 500,000 plays in total, summed up across all of your tracks, which sounds very optimistic to me. Then you're like 57% sure to go outside this number, which is huge. There's got to be something to it. So there's the listeners for the art. So 40,000 listeners is a minimum threshold you need to surpass, and the chances are pretty high. It's 92%. Doesn't sound too unreasonable, but 40,000 is still... I got like 48,000 subscribers on my Russian YouTube channel, and it took me almost 5 years to get there. So if you're persistent enough, I guess you get there. Okay. Oh, if you want to help me out, please do subscribe to the channel. It sends the YouTube algorithm a signal to promote my content. So please like, subscribe, and leave a comment down below if you don't mind. I gotta say, it kind of looks off to me. These are too optimistic. One thing we could check is how many tracks those artists published. I think our top threshold is 50. That's where we stopped. So we got top 50 tracks for each artist if they had 50. If they had less tracks, there's less tracks there. So how prolific you gotta be to have these numbers? So what's the minimum amount of tracks you need to publish to get there, to approach these probabilities? Let's count how many tracks each artist has in the dataset. Grouping by the artist name to get a list of unique artist names. We're aggregating by counting, and we rename the track name to track count. And we get these kind of numbers. Weird Al Yankovic. Let's see the distribution for that. Oh, that's weird. We got almost 10,000 artists there. Nearly all of them are above the 50 threshold. We can't really assign any tiers. We can say there's artists that are above 50 or below 50. That's pretty much it. So two groups. Let's assign those groups. If track count is below 50, it's a 0. If it's above or equals, it's a 1. So we get the track count tier, 1 or 0. It seems to have worked. 47 gives you a 0, 50 gives you a 1. And we merge this little data set with our initial large data sets so that we have the artist track count column and the artist count tier column. Okay, let's see the percentage. That's pretty small, almost negligible. But using that, we can later on compare if your success as an artist depends on the number of tracks. If having 50 or more tracks gives you a higher chance of success as compared to having less than 50 tracks published. I would expect having more tracks brings you more listeners, more exposure, more track plays. So our final conclusion today is the whole thing is pretty optimistic. You're very, very likely to achieve at least something as a musical artist. But it does look like you need to aim at having at least 50 tracks in your backlog to get there. Good luck with that. I really do hope your tracks pass these listener and play count milestones, because you're awesome. Yes, you are.